Today we're going to discuss about finding a and b of an exponential equation. Let us review the parts of an exponential equation. A is your initial point or the starting point. B is your growth factor. Just to further emphasize, the growth factor or the b is actually made up of two components. The first one is a constant of 1, plus or minus the rate, plus if it's growth, and minus if it's decay. Although this is how B is broken down, for this particular video, our focus will merely just be what is the initial point and what is the growth factor. X represents time. And lastly, Y is your answer, or we can sometimes call it also your function. Example number 1. Find a and b of an exponential function that passes through points 1, 26 and 5, 416. Let us begin. Step number 1. Make sure to label your given points. And then you're going to substitute the x and y values into the x and y of your given formula. And since you have 2 points, you're going to come up with systems of equation, meaning to say you will have two equations where you will have two different values for x and y. So for the first one, you're going to substitute 26 in place of this y value. And then you will copy down AB as is. And you're going to substitute in place of x 1. All right, so this is our first equation. Now let's come up with our next equation following the same procedure. So get 416, put it in place of y, copy down a and b, put 5 in place of x. When solving for a and b, we're going to follow the same algebraic procedure, which is to eliminate the variable that is possible to be eliminated so that you can isolate one of the variables. And then from there, you're going to be able to get the value of the second variable. So once again, your main goal is to isolate whichever variable you can isolate first. So looking at this, notice that A and A here are the same. So actually, if I divide this by this, you would be able to isolate your B. So that's what I'm going to do. I'm going to divide these two equations. However, I want to put this larger one on top and this below for the simple reason that if I keep it this way where the bigger exponent of b is down below, then I'm going to end up with a negative exponent. You have already taken that up in one of my videos. So for me to just to avoid a negative exponent, I want to go ahead and put this on the top, divide by this equation below. All right, so let's begin the dividing process. Cancel out a. B to the fifth power divide by B to the first power. You know the rule. Copy down the base, which is B, and subtract the exponent. So that's going to be B to the power of 4. Then 416 divided by 26. If you put that in the calculator, that's going to be 16. All right, so we're almost done. We just want the b to be by itself, so we don't want this 4. So therefore, for me to isolate my b, this has to be removed. You can either raise this to a power of 1/4 in order for you to cancel out the 4, or you can get the fourth root of b on both sides. Getting the fourth root of b is going to eliminate the power of 4. Whatever you do on the right, you do on the left. So now my b is equal to 2. Our next job is to find A. We're going to do that by substitution. Now that you know that your B represents 2, we're going to use one of these equations in order for us to substitute 2 in place of B. The best equation to use is the first one because this is just a B. We don't have to, if we use the second one, then I will have to raise 2 to the power of 5, and that will make it a larger number. And so I'm going to use the first one to substitute 2 in place of B so that we can solve for A. And then the next step, in order for us to isolate our A, is to divide both sides by 2. And 26 divided by 2 is 13. So A is equal to 13. Let us now go to example number 2. Example number 2. Find a and b of an exponential function that passes through points 1, comma 12 and 2, comma 48. Let us begin. First step is to label your points. Next step, substitute your values for x and y onto the equation. So for the first point, y is 12 equals a b to the power of 1. Equation number 2, y is 48 equals a b squared. So again, our main goal is to eliminate one of the variables so that we can isolate the other one and from there solve everything. The way I see this is pretty much the same as the first example. I can divide this 2 so that I can eliminate A and solve for B. I'm going to put the second equation on top of the first one in order for my exponent of B to be positive. All right, so this is now the equations. I'm now going to eliminate the a. And then let's divide b squared over b to the first. And you know that the rule says to subtract the exponents. So we will copy the base b, and 2 minus 1 is 1, or just a b, equals 48 divided by 12 is 4. So our b is 4. Let us now begin solving for a. All right. In order for me to solve for A, I'm going to have to use 4 to substitute in place of B. In either of the formula, even if I use 1 or formula number 2, I will get the same answer. However, taking a look at this, I think my work is going to be cut short if I'm going to use equation number 1. And that is because this is already just simply B. So I'll just have to substitute 4 in place of B and then isolate A. I know you all know this already, but I just want to once again emphasize the power of 1 is the same as just simply b. So if you don't see the power here, it does not mean it's 0. It means it's 1. We are not required to write it anymore, but it's understood that there's a 1 there. I'm just recommending this strategy, guys, that whenever you're doing substitution, you write the formula and then make sure that you don't substitute yet. Just replace that variable with a parentheses and then you plug. This eliminates all the confusion, especially when there are negative integers involved. And then we plugged in the 4. After you plug in the 4, for you to isolate your A, you will have to divide both sides by 4. So this side divided by 4 eliminates that 4. It turns to a 1. And then 12 divided by 4 is 3. Therefore, A is equal to 3. Last and final example. Find a and b of an exponential function that passes through points 0, 2, and 1, 10. For our first step, label all your points and then come up with systems of equation where you will replace those values in place of your x and y. So for our first point, the y is 2 equals a b to the power of 0. Equation number 2, y is 10 equals a b to the power of 10. So for this example, we're going to use a different approach only because if you are noticing this, this is b to the 0 power, and anything raised to 0 power other than 0, of course, is going to turn to 1. So this is already the value of a. A is 2. And let me show you why. This will be 2 equals a times 1 because b to the 0 turns to 1. And so a times 1 is just a. All right, so this is already our value of a. We're just going to use this in order to substitute and get the b. Now, I want you to remember this strategy and this process, okay? Whenever you came up with a value for a certain variable from one equation, you cannot get that and substitute again in that equation to solve for the other one. So remember that. We got the 2a from the first equation. So we got the a equals 2 from the first equation. And so therefore, for you to get the b, you're going to plug in this value, but on the second equation. So the first thing I did was to copy the whole equation number 2. And then we're going to copy it again, but whenever I get to A, I will replace it with parentheses. Then equals parentheses B to the 10th power. But guys, I am just now realizing this. I made a mistake from the very beginning, and I hope I'm glad I caught that right away. Right here, the power should be a 1. Okay, so 10 is the y, ab to the power of 1. So guys, it should be power of 1 from the beginning because that's our point. I apologize for that. All right, now that all the mistakes have been corrected, we're now going to plug in 2 in place of b again using equation number 2. All right, in order for us to isolate the b, we're going to divide both sides by 2. Cancel the 2. You're now down to just a b. And so b equals 5. All right, guys, so that is it for our video. I hope that you have learned a lot today.